So for those that don't know me, I'm Jake Kirby. I'm here in the biology department at USD. And so part of this experience, I'm sort of hosting and created this entire seminar series. So tonight is the first of this series. We have Dr. Gingerich here to talk to us about an astronomer, things relating to the universe. But this is just the first in many talks, so we have another 4 speakers also coming in to talk about various things also relating to science and faith. And so the motivation for me, sort of doing this and proposing this is I teach general biology and get a lot of freshman biology students that come in with certain perspectives and worldviews about evolution in particular, obviously. And sort of faced with, as a professor, sort of talking about the data and details of evolution. And sometimes I feel, a little bad for some students that I leave sort of shell-shocked and they really don't have anywhere to turn in terms of thinking about science and thinking about faith. Because as scientists, we may not engage in that discussion, and the pastors may not know enough about the science to actually engage in it either. So that's kind of the motivation behind this series is to present some sides talking about sort of the engagement and emerging of both of these. I feel like there's enough yelling from either side that you can hear that quite plainly. But more it's, in an academic sense, more fruitful to sort of talk about what we have in common. And so that's sort of the doing of what I have here. So this is all from an actual grant that I wrote with Reverend Steve Miller of the United Church of Christ down the road here. So we actually have a website, cultureandquestions.com. It's not 2000, we don't have a website, of course, right? So on that website, if you go to that, cultureandquestions.com, you can see the other lectures that we have coming. The next lecture, just to keep you apprised, is March 6th. That will be Bob Hazen, who's from the Carnegie Institution in DC, and he'll talk to us about the origin of life from a scientist's perspective. And then actually the week following that, March 13th, we'll have Lauren Brown, who's from Fuller Theological Seminary. So sort of a different take altogether. Okay. Also, sort of just to briefly engage that too, you'll see on the website, we'll have this series of 5 national speakers coming in. But in addition to that, we have more sort of social gathering. So this is obviously a formal lecture, and we'll have some time for questions at the end. But along with each of these, we have what we're calling a salon. And that's basically an idea, not where you get your hair done, but a discussion group where we have a local scientist come in and talk to us about these sort of issues. So Tina Keller from the physics department gave us a nice talk on the origin of the universe, and we had a nice discussion around sort of a reading tables about what that means in terms of everybody's worldviews. So we have one of those as well. Look for those on the website again if you're interested in attending those. And that next one will be given by our own Howard Coker, who's an undergraduate in the chemistry department. And his will be February 13th. So again, just look at the website for any of that stuff. The format for tonight's lecture is basically, I'll turn it over in a minute here for our speaker tonight. He'll give a lecture, maybe 30, 40 minutes long, sort of presenting his views. From the previous salon with Dr. Keller, a lot of us came up with some questions, so I'll lead off with a question from that group, and then sort of pepper in other questions. But of course, you all here listen to the lecture, so I invite you guys to ask questions as well, and I'll turn it over and give you an opportunity to do that. Okay? And then that's how we'll end it. So, without further ado then, I'm going to introduce Dr. Owen Gingerich, emeritus professor from Harvard University. Dr. Gingerich is a professor in both astronomy and also in history, so he presents some interesting viewpoints. A lot of his specialization has been on Kepler, Copernicus, Galileo, these sort of old figures in science that had to grapple and deal with the church, so pretty relevant to what we do now. But he's also sort of well known in his own field as well. So the title of his lecture tonight is The Divine Handiwork, Evolution, and the Wonder of Life. So please help me in greeting this question.
Good evening, ladies and gentlemen. It's nice to see that despite the rather dismal weather, so many of you have actually practically filled this hall to overflowing. I've taken my title, The Divine Handiwork, from the 16th century astronomer Nicholas Copernicus, who at the end of his wonderful cosmological chapter exclaimed, "So vast, without any question, is the divine handiwork of the Almighty Creator." When Copernicus proposed that the sun rather than the earth was the center of the universe, he realized that the annual motion of the earth around the sun would cause a periodic shift in the positions of the stars, unless they were much farther away than commonly supposed. But Copernicus scarcely had a clue about the true vastness of the heavens, something that became understood only in the 20th century. And this change from the closed world of antiquity in the Middle Ages to the near infinite universe of today has forced a change, still resisted by many, in the way we look at our sacred scriptures, and in particular, the book of Genesis with its vivid story of Adam and Eve. So let me begin with a brief history of the geological column. The geological column is the arrangement of stratified sedimentary rocks into a tall stack with the oldest rocks at the bottom and ever more recent rocks as you go up the column. It would be neat if we could find somewhere all the layers of rocks stacked up in a sequence where we could look at them. But we could hardly expect that. Besides the processes that deposit the materials that will eventually be pressed into rocks, there's also the erosion that will wear them away. Furthermore, environments change. And where once there was a shore where tides deposited repeated layers of silt, it can later become dry land. So constructing the geological column was a daunting task, something like a three-dimensional crossword puzzle. It would take much more than an hour to review the history of this ongoing scientific effort, but let me give you a few vignettes. In the 1830s, the geology professor at the University of Cambridge, Adam Sedgwick, worked with the gentleman geologist Roderick Impey Murchison to examine the rock strata in Wales. It became clear that the strata were tilted, so that the further west one went, the older the exposed layers were. That is, the layers in the British Midlands overlaid those in Wales. Sedgwick called his series of strata Cambrian, after the Latin name for Wales, Cambria. Murchison, working from the Midlands to the west, called his system Silurian, after the Silures, an ancient British tribe. What Sedgwick called Upper Cambrian, Murchison called Lower Silurian, and there was a fierce falling out between the two geologists. Only in the 1870s was a so-called unconformity found in a humble rock exposure along the River Olney in Yorkshire, signaling an episode of erosion that broke the continuity of the two systems. Well, I'm tempted to discuss the Permian geological period and the enormous extinction that closed it and the entire Paleolithic era, when 96% of all marine species and 70% of terrestrial vertebrate species perished. And likewise, I'm tempted to mention the age of dinosaurs that followed the so-called Mesozoic, or middle period of life, and the mass extinction that ended that era. But I must get to the bottom line. The geological column is very real, and the oil exploration industry continually relies on its efficacy. Let me emphasize that the most significant aspect of the geological column is that the oldest layers show only quite primitive life. And the higher we go in the column, the larger and more complex the life forms become. Now, let's reflect on the impact of all this on our understanding of the days of creation outlined in the first chapter of Genesis. You'll recall that not until the fifth day comes the creation of the watery creatures, specifically the giant whales, and also the birds of the air. And on the sixth day come the cattle, the lizards, and snakes, and finally humankind. Note that plants, including grass and fruit trees, have already appeared in the third day. In comparing these sparse details with the fossil record in the geological column, we can see that the separation of the fifth and sixth day is pretty arbitrary, more poetic than scientific. Birds come rather late in the fossil record, while skeletons of early whales that have legs, showing that they have moved in from the land, indicate that the distinction between land and sea and air is very problematic. And the fossil record of plants come well after the first sea creatures. But long before this geological knowledge was achieved, scholars have pointed out that Genesis 1 was a rhetorical construction, not a literal historical reading. But let me go to another aspect of the geological column. One of the great scientific achievements of the 20th century was the use of radioactivity to determine specific ages for the geologic periods. Radioactive elements with known half-lives provide atomic clocks that can be used to date specific rock layers. If the Earth were infinitely old, the unstable radioactive elements would have long since decayed and we would not find them. But because we do find them, we know that the world is not infinitely old. And from their abundances, compared with the now inert decay products, we can deduce their ages. By careful determinations of the abundances of various isotopes, it's possible, for example, to place an age of 550 million years to the beginning of the Cambrian period, and so on. The range of dates goes from 4.6 billion years for the oldest meteorites, which correspond to the formation of the solar system, right down to 200,000 years for the stratum in which an anatomically modern Homo sapiens skull was found. This vast panorama of dates on the scientific tapestry stands in stunning contrast to the brief 6 days of creation in the biblical picture. A natural possibility among those attempting to save an almost literal reading of the scriptures is to suggest that the days of Genesis are actually immense periods of time. After all, Psalm 90 states that 1,000 years is as but yesterday to the Lord. But such a scheme produces at best a very strange compatibilism. It just isn't convincing when you look in detail at what the days of Genesis entail. As a part of its poetic structure, a paean to God's stupendous creativity, representative aspects are singled out and placed in their pigeonholes of a few days. But if we take the scientific evidence seriously, the claim that the days of Genesis are literal 24-hour days is an exercise in futility. To declare that God created the fossils and radioactive isotopes in place to mislead us suggests a trickster God, something I'm not prepared to accept. And besides, it can lead to the repulse that everything, our memories included, were created just last Saturday. But why, earnest Christians have from time to time asked me, does the universe have to be so big and so old? We seem to be such small specks in the vastness of space, and we dwell in such a small temporal interval compared to the sweep of time. Well, I can't really answer that. Since I believe in a powerful creating God, I suppose there are probably many ways that universes could have been made. Perhaps part of the purpose and challenge of the universe is for us to find out which way God did it. And what we have learned about this particular universe is that if we're not enormously old, we wouldn't be here. In the beginning, in that almost incomprehensible moment of creation, the Big Bang, the heavier elements required for life were not formed. Out of the Big Bang came hydrogen and helium and a very tiny percentage of lithium, but not carbon and oxygen and iron, to name a few particularly critical atoms. It took billions of years in the fiery cauldrons of giant stars to cook up the carbon and oxygen needed for the organic chemistry of life. And so the story of life becomes, in the scientific picture, a much richer and complex retelling than the simple mythic presentation in the opening verses of the Bible. As Galileo said, the Bible teaches how to go to heaven, not how the heavens go. We should not look to the Bible as a scientific textbook, but as an inspired document created within a pre-scientific culture. We should not say that the Bible is unreliable because it says that the sun and moon were created after the plants of the field, but we should ask, what genre of literature is it at this particular point, remembering that the Bible is not so much a unified book as a whole library. And we should ask, what is the Scripture's fundamental meaning? As a matter of fact, the Bible doesn't say that God created the sun and moon. I suspect some of you must be thinking, but I'm sure it says in Genesis 1 that God created the sun and moon. Wrong. What it says is that God created a lesser light and a greater light. Why the circumlocution? Because in neighboring Babylon, the words for sun and moon were deities, and the author or editor of Genesis wanted to separate the Hebrews from the surrounding cultures to focus on the specific, powerful action of a monotheistic God, and to distance themselves from an accidental universe rising from the chaotic, battling forces of good and evil. So we might better read the opening verses of Genesis as a political statement rather than as a scientific treatise. But let us turn from the world of the large to the world of the small. When I was in graduate school 50 years ago, there was still controversy about precisely how many chromosomes there were in human cells. If you look at a picture of all the chromosomes and you start trying to count them, you discover quickly why the confusion. Today, however, even middle school students can learn that there are 23 pairs of chromosomes in human cells, that these chromosomes are tiny coils of DNA, and that the DNA contains coding for the chemical machinery that operates the cells. This chemical machinery consists primarily of proteins, which are strings of amino acids that can fold up into a variety of shapes. There are 20 amino acids normally used in the proteins, and stringing them together in different combinations can give an incomprehensible number of possibilities. The Nobel biochemist Christian Dew has calculated that if you want to make just one each of every possible 50-unit protein, the total mass would far exceed the mass of our Milky Way galaxy. The DNA codes for the amino acid sequences is essentially a spiral staircase with pairs of 4 nucleic acids forming the rungs. So, vast sections of the approximately 3 billion base rungs in the DNA staircases of the human genome are arranged in triplet patterns that code for the 20 different amino acids used in making human proteins. At the same time, even larger sections, over 98% of the DNA, does not code for proteins. This puzzling so-called junk DNA appears sometimes between the genes, but often interrupting the gene sequences themselves. They are more formally called the introns, and I shall return to them presently. Now, keeping the 3 billion nucleic acids in order in each of the tens of trillions of cells in our bodies is a hopeless task, and mutations are continually taking place. The cells have a pretty good defense against this because most chromosomes come in pairs. One of each pair from your mother and one from your father, and if one is defective, the other can dominate. So mostly mutations won't matter, both because of the backup and because generally they aren't going anywhere. Only in the germ cells can a mutation be transmitted to an offspring. But because mutations have happened over the ages and are continually happening, no two persons, except identical twins, have exactly the same DNA, something that has become exceedingly valuable in police forensics work. Interestingly, Not all of the genetic blueprint is located in the chromosomes, however. A small amount of additional DNA, only 37 genes, is found in the mitochondrion of each cell. And this genetic material comes only through the maternal line. Throughout the world, the mitochondrial DNA is essentially the same, meaning that we all share a common female ancestor who's been termed the mitochondrial allele. From mutational variations, it's possible to make an estimate of how far back she was, something between 100 and 200,000 years ago. This does not mean there was a lone woman or that her contemporaries are not ancestors of those among us. The other women simply did not give rise to an uninterrupted maternal line. Likewise, the male sex chromosome is transmitted only through the paternal line, so it's possible to try to date the Y chromosomal adult, but apparently he's not as long gone as the mitochondrial E. The most recent common male ancestor seems to have lived perhaps 60,000 years ago. In other words, science does not point to an original couple. Thus, the mitochondrial Eve does not substantiate the existence of a biblical Eve. In fact, these dates, plus the dates for the fossil skeletons, or even the age of the wonderful cave art at Lascaux, tell us that Homo sapiens has been around far longer than the Adam and Eve of Genesis 2. So again, the science of the last century forces us to reconsider how we interpret the biblical account. By now, many of you might have noticed that although the title of my talk includes the seemingly controversial E word, evolution, I hadn't yet mentioned it. Precisely because the word is much debated in our national scene today, I wanted in the first place to show you the great extent to which modern science, completely independently of evolution, seems to impinge on a literal understanding of the Bible. I hope that I have demonstrated that much of the Bible is framed by a pre-scientific cosmology, and that to accept modern science in its full tapestry, which includes not only X-rays, influenza vaccine, laser CD readers, and cell phones, but also means accepting a vast and ancient cosmos and a gradual development of life on Earth. Making peace with both science and the Bible requires an open-minded consideration of biblical interpretation that goes beyond scriptural literalism. Thus, let me now turn to the theory of evolution so that we can explore where the areas of tension might lie. Most of the science I've described this evening was pretty much unknown to the 22-year-old Charles Darwin when he embarked on his famous voyage of the Beagle in 1831. By the time he published his Origin of Species 28 years later, he had a good understanding of the geological column, the fact that it represented a great span of time, and that the organisms preserved in the fossil record gradually became more complex. That is, that somehow the flora and fauna evolved. But how could this happen? Darwin had barely a clue about genetics, though he understood the variations that could be introduced through selective breeding. He was, however, essentially baffled about how variations could arise. But given that they did appear, his genius was to suggest that, given enough time, natural selection plus common descent with modification could accomplish the task. Natural selection seems obvious enough, though his contemporaries were reluctant to accept it. They were shocked at the idea of an over-fecundity in nature, more offspring than the world could accommodate, and the death of the least fit. Ultimately, his second axiom, common descent with modification, became the more radical idea. It meant that every creature had a parent. No fly just emerged from the garbage without a mother, reasonable as this might have seemed to 19th century observers. But Darwin's proposal had the radical implication that sometimes the offspring varied enough from the parents to become a new species. And here was Darwin's dilemma: how to create an eye. Since variations seemed to be small, how could a minor fraction of a proto-eye be sufficiently more fit to be selected for? How can you get the big jumps that produce enough change to make a new species? The dilemma is related to a query raised by Pierre Leconte de Noy over half a century ago in his book, Human Destiny. Leconte argued that to assemble a 2,000 atom protein by random shakings had a probability of 1 chance in 10 to the 321st, which is a pretty big number. Clearly, random shakings are not the way to build complex molecules. Leconte went on to say that to achieve such a result, we had to call on what Eddington expressed as anti-chance, or as Leconte implied, a miraculous intervention. But there are other possible pathways. For instance, the formation of a long protein becomes much easier if it's built up from subunits. And that seems to be precisely how some of the assemblies take place in human cells. When the Human Genome Project announced its preliminary results a decade ago, one of the most unexpected aspects was the shockingly small number of genes. That is, there's coding for only about some 22,000 proteins. The millimeter-long worm, C. elegans, the only nematode to have its DNA completely sequenced in that early time, has about 19,000 genes. How can humans be so much more complicated than a tiny worm when we have only 3,000 more genes? But today, biogeneticists are discovering that our cells can make far more than the 22,000 proteins by splicing together pieces from existing genes to make numerous additional protein molecules. But where are the instructions for this? It has long been suspected that the so-called junk DNA has important control functions. And only now are biogeneticists beginning to find out how the cut and splice instructions are embedded in these introns. Clearly, the developmental sequence for making different kinds of cells depends on a complex orchestration of many genes working together through some sort of interconnected control structure. And if something goes wrong early in the control pathways, an entire cascade of effects can be thrown out of kilter. And only in the past couple of decades have the effects of the so-called Hox genes begun to be explored and understood. These genes control the body plans, and once these patterns are set, many of the subsequent steps take place more or less automatically. One of the most exciting aspects of evolution today is seeing how changes at the species level might take place in a major jump with a relatively small change in the control specification. Let's hark back to Darwin's dilemma, how to make the eye in seemingly small steps. The late Ernst Mayr, the Dean of American Evolutionists, remarked that the eye had been independently invented a few dozen times, presumably by small steps. What he did not know was that there seems to be an underlying gene at the control level that is common for all the very different forms of eyes. Evolution seems to have had a head start when it came to making eyes. In its details, evolution is far from being a finished theory, but as an explanatory system, evolution has much to offer. Look at your hands and your feet with their 5 digits, and then visit a comparative zoology museum and notice how the 5 sets of bones goes from the fins of the coelacanth right up the vertebrate tree. For proponents of intelligent design, these observations are a set of unrelated facts, facts in themselves, in the vocabulary of Aristotelian logic. But for the evolutionists, they are reasoned facts, observations with connectivity. The pattern of 5 digits among the vertebrates becomes compelling evidence for the idea of evolution, which turns facts in themselves into reasoned facts. But there's another category of observations where evolution offers persuasive explanations, the observations of imperfect design. Darwin gathered a number of examples, not all correct, but nevertheless enough of them to make the point. My favorite example is the red-footed booby on Genovesa Island in the Galapagos. It's ridiculous having web-footed boobies trying to nest and hang on in trees. This unusual adaptation arose because the blue-footed boobies and magnificent frigates had already taken over the ground-based ecological niches. Just a moment ago, I alluded in passing to intelligent design, a scheme that is controversially now advocated in some quarters as an alternative to evolution, to the extent that it should be taught as a viable option in biology classrooms. To me, this is a serious category error. Let me try to make that clear by considering a simple question posed by Sir John Polkinghorne. Why is the water in the tea kettle boiling? Well, we can answer that the water is boiling because the heat from the fire raises the temperature of the water, till the molecules move faster and faster that some escape from the surface and become a gas. But we can also answer that the water in the tea kettle is boiling because we want some tea. Well, the first answer illustrates what Aristotle called an efficient cause, an explanation of how the phenomenon takes place, while the second answer, because we want some tea, is a final cause, the reason why the phenomenon takes place. One aspect of the scientific revolution of the 17th century was that it turned away from the final causes so central in the Aristotelian worldview and concentrated on efficient causes, the how of the phenomenon. To me, belief in a final cause, a creator God, gives a coherent understanding of why the universe seems so congenially designed for the existence of intelligent, self-reflecting life. Only small changes in numerous physical constants would render the universe uninhabitable. Somehow, in the words of Freeman Dyson, this is a universe that knew we were coming. I do not claim this as a proof for the existence of a creator, only that to me, the universe makes more sense with this understanding. On the other hand, as a scientist, I'm interested to know the how, as well as the why of the universe. I want a coherent picture of how Homo sapiens came to be. How come our DNA is so wondrously related to all forms of life? How atoms emerged. And this understanding of how the universe works, the efficient causes, comes from the great tapestry of science, which includes the theory of biological evolution. The weft of this tapestry are the observations of nature, while the warp is the framework of theoretical constructions that holds the explanations together. This great tapestry is of a piece, and it's difficult to tear out one segment without unraveling huge sections of this grand picture. Yet, this is precisely what some fundamentalists are trying to do in their attacks on biological evolution. Here I've tried to depict parts of the great tapestry that stand quite independently of evolutionary theory, such as the geological column, the ages of the rocks, or the way the DNA codes for the machinery of life. And yet, these are essential threads for understanding how evolution fits into the scientific explanatory picture. I understand that these topics may feel threatening to someone who reads Genesis 1 as verbatim history. But I think that evolution is a very scary topic even for persons who take a more metaphorical view of the early parts of Genesis. And why is this the case? Where are the tension points between religious belief and the idea of evolution? I suspect that a great deal of this has to do with the place of humankind in the animal kingdom. We're intimately related to the animal kingdom, as our shared DNA makes so richly obvious. Our DNA differs from chimpanzees by only a couple of percent or less, although very much so in the more critical portions of it. Are we simply a glorious accident, the result of random mutations? If that is the bottom line of evolution, that we are curiously intelligent beasts in a purposeless universe, little more than the apes in our family tree, then there are strong religious grounds for resisting evolution. That we are little more than apes can well be a philosophical viewpoint, and it is the chosen viewpoint of some practitioners, but it's not intrinsic in evolution. I'm on record as saying that I'm psychologically incapable of believing in a purposeless universe. So I ask the question, what does it mean to be human? And I look to the most important verse of Genesis 1. God created man in his own image. Male and female created he them. In other words, there is in each of us a divine creative spark, a touch of the infinite, conscience, and self-consciousness. These are truly human attributes, and we may well inquire when in our long evolutionary history they arrived. Did the crossover point come 200 millennia ago with modern Homo sapiens? We shouldn't confuse humanness with skeletons. Conscience is something that doesn't fossilize. I must confess that the moment of becoming human is not a query that I propose to answer this evening. I only want to underscore it is a very interesting question worth thinking about. But before I close, I want to return to the story of Adam and Eve and the tree of good and evil. Surely this is a powerful metaphor about the origin of conscience and becoming human. With the God-given attribute of conscience, the understanding of right and wrong, comes responsibility, decision-making, and the ability to make wrong choices. For me, the story of Adam and Eve and the fall is the story of becoming human. It's not important to me whether Adam and Eve were a historical couple. What is important is to see the Bible taking as its starting point the emergence of our humanness, the origin of humanity. If we keep this as a central issue in our understanding of why we are special in the cosmos, then I think we should have no trouble in accepting evolution as a major explanatory scheme in comprehending the natural world. As Darwin wrote at the end of On the Origin of Species, quote, "There is a grandeur in this view of life with its several powers, having been originally breathed by the Creator into a few forms or into one, and that, whilst this planet has gone cycling on according to the fixed law of gravity, from so simple a beginning, endless forms, most beautiful and wonderful, have been and are being evolved." But I choose not to end with Darwin. Instead, I elect Copernicus for this role. So vast, without any question, is the divine handiwork of the Almighty Creator. Thank you.
Thanks. So now what I'll do is, you guys can think of some questions you have. I have a few questions. I can't see the iPhone here. So I'll lead us off with a question, and then I'll sort turn it over to someone in the audience who has a question. So you mentioned briefly this sort of tension in terms of evolution and intelligent design, and you use that term intelligent design in your lecture tonight. And maybe you could sort of conceptualize that a little bit more in terms of your lecture focused a lot on sort of the process of evolution and things like that. But you, at some level, say that you're not a proponent of intelligent design, yet you talk about a creator. Maybe you could sort of redefine those a little bit for us.
I'm on record as saying that I believe in intelligent design because I believe in an intelligent creator. Intelligent design with a lowercase I and a lowercase d. Now, there is also intelligent design with an uppercase I and an uppercase D, which I consider almost verging on a political movement, which is an attempt somehow to replace the how theory of evolution. And it's also a kind of scheme to, in fact, prove the existence of God. And I'm not quite sure that the universe has obvious proofs. I think it's an understanding that we can come to make everything more coherent and hang together in a way that helps us understand the really big pictures. But I don't think there's a way that science will bludgeon us into thinking that God exists. I think that faith in God is a much more subtle thing than that. So the public relations officer at the Smithsonian Observatory where I work said, you can't say you believe in intelligent design. That doesn't, lowercase, people won't get it. But a lot of people have got it. This idea of the difference between the upper and lowercase things is working its way into the literature.
Okay. Is anyone in the audience have a question? I'm sure you do. Come on. I'll look at the next one.
I can't believe that you all accepted every single thing I said. So maybe you want some further elaboration, or you want to refute me.
You said that the universe was congenially designed for humans. Is that a fair statement? If I were to somehow be transported 2 miles vertically up, I would die. And the rest of the universe is, as far as we know, completely uninhabitable to me and the rest of us. So statistically speaking, we have one tiny little planet with life on it, and as you said, a virtually infinite universe that's uninhabitable as far as we know. It doesn't sound like the universe is designed for life.
If you want to approach it in a quite different way and start looking at the some of the physical design of the universe, if you change those numbers just slightly, we couldn't be here at all. So there are a lot of aspects of the universe. For example, the amount of energy with which the universe began its expansion, so that we have, as a consequence, what we call technically a flat universe. If the universe had expanded more violently in the Big Bang, the density of the material in the universe would have been, it would become too tenuous too quickly. We wouldn't have the stars forming, and therefore the galaxies and so on. There wouldn't be places for us. On the other hand, if we started it out without enough energy of expansion, the universe would have collapsed back in again, long before there would be the long periods needed to cook up the carbon and so on. So this is a fantastic fine-tuning to get it just so. That's an example of a number of physical constants in the universe. But it's quite wonderful that we have a congenial home, even though it is on a comparatively small planet in the vastness of the universe. So we have to be careful. We don't want to extinguish ourselves by being stupid. Sometimes humankind is capable of. If we're alone in the universe, we should really take care of it.
Yeah, it may be hard for citizens of South Dakota to understand a congenial environment to live in, right?
Okay, so do you see human life as a sort of end game, end result of evolution?
Or is it going to continue on? We are now at a kind of a crossover point where the human brain's information capacity is larger than the DNA coding capacity. And in addition to the fact that we can have externally to the brain libraries and so on of information. So we're in what we might call a Lamarckian mode of being able to influence our own evolution. And so that the evolutionary scheme that has brought us to this point is at a threshold of making a considerable kind of change. I remark again, as I did at the beginning, that the human brain is by far the most complex thing we know of in the entire universe. If you want to continue.
Yeah, I mainly brought this up as a point to bring up in what you said of fine-tuning, because if the universe, some concept of the universe was slightly different, there may still be an end result like humans, but it doesn't necessarily have to be humans. It doesn't, we don't need quite the amount of fine-tuning to still come up with some intelligent life. It is the amount we have to come up with us. So intelligent life could have existed without the same amount of fine-tuning, right?
No, I don't think so. It is because we have to have some kind of a chemistry that is going to allow for the complexity which we have. And it is very difficult for us to imagine this happening, for example, in anything other than carbon chemistry, let's say. So you could imagine that a process of evolution could turn up with creatures that are very different from us and yet have intelligence. But I think they would have many of the same physical or chemical attributes because we can see that they are, in so many instances, greatly optimized in terms of what the possible range is.
Brought this up a number of times on this carbon-based life. Now, we can take this as a literal interpretation of the Bible, and where we are now, a literal interpretation of science. Where decades ago, everybody was told life can't exist anywhere else because you need water, oxygen, carbon-based, whatever. But there have been life forms found on this planet that exist without some of those things. There's bacteria that live in lava beds at the bottom of the Marianas Trench. So the caveat is life as we know it.
Oh, with the extremophiles, we are certainly getting a much broader picture of how present life can be in what appear to be very adverse circumstances. But all of that is still done with carbon chemistry.
But couldn't life exist without other things under different circumstances? There's a life as we understand, as we know.
Well, it's very difficult to talk about life as we don't know it. The more we look into these things, the more remarkable it seems to be. We get a much greater range of the existence of life now, but we still, if we're talking about intelligent life, we don't come up with it through the pathway of the extremophiles.
Any other questions? Yeah.
In your comments regarding life based on carbon, water, etc., are you singling out intelligent life or all forms of life?
Let me go off on a tangent on that one and come back to help you understand what I'm talking about here. One of the most exciting areas of research at the moment in astronomy is looking for the exoplanets. These are the planets around other stars. And there is a satellite spacecraft up there, the Kepler mission, which is continually monitoring a large field of stars near the summer Milky Way, looking for tiny variations of light when a planet makes a transit in front of the star. And we've now got several hundred of these planets around distant stars. Just in the last few weeks, it's been announced that 2 Earth-sized planets have been found. The problem is, these Earth-sized planets are very, very close to the stars, the primary stars, so that the temperatures are in thousands of degrees. So it's not habitable planets. Now, it's going to be much harder to get the planets that are farther away from the stars. If my face is a star and my finger is one of these planets, you see if it's going around my head very close to my head, the chances of going in front are rather high. Whereas if I could hold my finger out here 20 feet in front of me, a very slight tilt, and it's not going to go in front of the star. So the chances of finding one of these that's really, really close to the star is ever so much higher than getting one that, let us say, is out so that the period of revolution is a year. And it makes it much harder for them to find that. If you have to wait a year, the satellite might be dead. I mean, so that's kind of tricky. But suppose we get one that's in the right temperature zone and Earth size, so it's a candidate for having a habitat similar to the Earth. How can we tell if there's life on it? One thing we know is that the oxygen in our atmosphere is a very active element. If you just let it alone, everything rusts and the oxygen disappears. So the oxygen is continually replenished, and it's replenished because of the forces of life. The operation of plants that can break up water molecules and release the oxygen into the atmosphere. So it might be possible, with the right kind of spectrum analysis, to pick up that signal of an oxygen atmosphere. Okay, so you've got that. Now we're back to the question you asked about what kinds of life might there be. If you looked at the Earth over a few billion years, most of the time there would only be single-celled life forms, not intelligent life at all. Intelligent life is a very momentary thing in terms of the great, vast geological history of the Earth. On these distant stars, you get that signal. You haven't any clue what kind of chemistry is going on in that life. It'll probably be controversial as to whether it's necessarily life. Maybe some other chemical process can generate the oxygen. So the universe can be absolutely teeming with life, very hard to find it. That life, the chances are huge that it's very primitive, low form. The chances of finding intelligent life someplace else is going to be rare.
Okay, I think, well, I got one more question there.
I'm just curious, I want to get a better sense of your beliefs that you're talking about. So, in one sense, you're saying that you believe there needs to be a designer because you need to believe that there is a goal, a purpose.
That's certainly part of it, of course.
And do you believe that designer intervened at one point to direct things, or do you see that as a continuous force in the world?
I would say that I believe in a God that can interact with the world and with those of us in it. But how frequent this is something that's difficult to ascertain or even imagine. But I would suppose that a creator might like to give some impression of fundamental principles of love in the universe. And that is going to come through inspired people, intelligences on the earth, helping to give us this kind of a story that might ultimately be the salvation for humankind, to learn a little bit more about love and unselfishness.
Okay, we'll end there. Thanks again for coming. So I'll note too that actually I'm going to take Dr. Gingerich over now.